All right, so as we saw in the previous example, completing a square is kind of a pain when it comes to solving. And so we're not going to want to do that moving forward. So I'm going to show you the derivation of the quadratic formula. And I'll try to explain the key points, but I'm also going to try to fast forward through certain parts because it can be a little tedious. So first off, let's get that c over to the other side, kind of like we did in the previous example. All right, now that we have the c on the other side, I need to get that a away from the x squared. So I'm going to factor out an a. All right, now again, hopefully this makes sense. If it doesn't, multiply that a times the b over a, and you'll see that it just gets us back to bx, right? Now, I need to complete my square. Now, I need to come up with two numbers that add up, or when I multiply by 2, I get b over a times x. Now, to complete my square, I know that these two boxes here have to be the same, and they have to add up to b over a times x. Well, what could those be? I know that I need a number plus itself that equals b over a to the x, right? Trying to come up with two numbers that add, or the same number that adds up to that. So oh, there we go. So I know I'm going to have b over 2a here, x here, and b over 2a x here. Well, that should hopefully allow me to find the other values. It's going to be b over 2a here, and b over 2a there. And then that leaves me with b squared over 4a squared here. So that's the number I need. So I'm going to go ahead and add that in right here. But just like in the other example, I know that really it's a times that I have right here. Okay, so I'm going to add b squared over 4a to this side. Okay? One of those a's cancels in the denominator. Well, I should be good to go now that my equation's balanced and I know what my factors are. All right, that's looking pretty good. So I need to get rid of that 1a, and I'm going to multiply by 1 over a to do that. So I need to combine these together because it's easier to take the square root of a monomial than a binomial. So I'm going to multiply the top and bottom here by 4a to get a common denominator. All right, and those of you who are familiar with the formula are probably starting to see it. So let's finish this up. Oh, lo and behold, those have the same denominators. So let's combine those together and we are done. Oh, lo and behold, those have the same denominators. So let's combine them together and we're done. And that is why I mentioned that I don't really see a particular point in solving or in using completing the square to solve things when really we do it this one time. Super easy, right? and we can just reuse this formula over and over and